Hello friends, today I thought of checking with respect to performance tuning how much Copilot can help us. So what I have done is I have taken this SQL statement. Now let us see how Copilot is going to help us. So this query is running slow, so that is what I told to Copilot. You can see this is the prompt. This SQL is running slow, can you suggest tuning tips? So I have given very basic prompt, nothing detailed. So let us see what information it has given. So it suggested me some tips. Let us see one by one. Before going into the tips, let us see, this is the query. So this query is retrieving data from orders table, order items table and products table, and there is one where condition which involves the date data type and some filtering conditions. Also one order by is there. So this is the SQL which is given to us for tuning. So I pasted here and now Copilot is giving me the tips. So first is index optimization. So it is telling first ensure order date, orders in orders table, customer ID. These particular columns are having indexed or not. So it is asking us to check. Okay. And use composite indexes if filtering and joining on multiple columns. But I want to tell you something. Okay, indexes exist or not, that's fine. But just for one particular query, we can't create indexes. In that way, what will happen is columns will be having more indexes and thereby your updates, inserts, all such activities will become slow. And also in big projects or small projects, we have to take DBA permission to create index. Even if you send a request, we have to give the proper inputs why you want index on this. You have to justify your index creation activity. So sometimes it may not be possible, sometimes it may be possible. So this is one possible solution. What I want to emphasize through this exercise is, okay, we can use artificial intelligence for tuning purpose, but first we should know what exactly we have to do. First we should know where is the problem and what we should do. So here, though artificial intelligence has given us 6 options, but we should have some natural intelligence to find out which is more suitable to this particular tuning SQL problem. Okay, so this may be, may not be. So coming to the next one, avoid functions on indexed columns. That is the second tip which Copilot has given me. So in the query there is a to date, that is fine, but make sure order date is stored as a date data type. Assuming that date data type is not there. Sometimes what happens in loading activities, dates are stored in varchar2 format in Oracle because in the loading there could be lot many issues. In the final table, maybe that column might have been designated as date data type, but not always this is possible. So this may not be possible. So it is telling avoid functions on indexed columns. But if the business requirement is like that, if you want to filter out the data, so you have to use this to date function. Not always we can't get away with functions. So this may not be possible. What it is telling, order date is stored as data type, that is one, and if order date is a string or timestamp, convert it once during indexing or use bind variables. So to follow this we have to know lot of information. How much data is there in this particular table, what exactly the explain plan is showing. So unless we analyze, we can't say whether this tip given by Copilot is working or not. So that is about avoid functions on indexed columns. To finalize whether this will work or not, we need more information. How do we know more information? Unless you have tuning basics, we won't be in a position to say which tip will work or not. Coming to the third one, that is check join cardinality. Check join cardinality is the third tip given by the Copilot. Here it is telling use explain plan to see if joins are causing full table scans. If order items or products are large, consider materialized views or pre-aggregated tables. Again, coming back to this explain plan, fine, we can see and we can find out whether valid full table scans are there or unwanted full table scans are there. And also not always full table scans are good or bad. So based upon the retrieval result, sometimes even full table scans are also good. That we have to finalize. Coming to next one is create materialized views or pre-aggregated tables. This is something design aspect. We can't just like that create materialized view or pre-aggregated tables. For this also you have to first check in the development and then send it to DBA, giving you a justification, and it is not a quick process. It is design change, so it will take time. So check join cardinality may or may not work. Okay, so to emphasize whether it will work or not, first we should have the basics of performance tuning. Fourth one is limit result set early. What does it mean? Here it is giving fetch first 100 rows only. So this will work only for OLTP kind of projects or queries. If it is a warehouse, then what is the use of getting 100 rows as soon as possible, right? So this tip to use, you should know that when to use this first 100 rows, first n rows that. Coming to next one, it is telling where row num is less than or equal to. Even this is also same, fetching first 100 rows as soon as possible. So this solution will work only for the OLTP web enabled applications queries, not for warehousing kind of queries where lot of millions of data will be there. So there is no point of just getting 100 rows first and then the entire query result is taking more time. To know that whether to use this or not, first you should know what exactly fetching first 100 rows, when to use, where to use. Okay, next coming into the fifth tip, use exist instead of join if applicable. If you are not selecting columns from all tables, replace some joins with exists can reduce row explosion. Fine, this suggestion is good, but for this also we have to do the basic analysis. Each table, how much data is there? This filter condition is retrieving how many rows. So because not always exists will work. Exists will work only in certain conditions. So to follow this, you should know when to use exist clause, when not to use. Again, we are going back. One should know the performance tuning basics. Coming to sixth tip, partitioning. When to go for partitioning, when not to go for partitioning, which column to partition, which column not to partitioning. Okay, so the knowledge is required to finalize which solution will work for us. Coming to, it is telling use CTE or temp tables for reuse. Temp tables for reuse. If you are using this query repeatedly, store intermediate results in temporary or common table expressions. Again, this is also your design change. So even the temp tables, there are a lot many different kinds of temp tables are there, whether session specific or transaction specific. All these concepts, if you know, then only you can finalize whether to go for temp tables and which type of temp tables. So ultimately what I would like to say is, okay, we have artificial intelligence, we can take help of such tools, ChatGPT, Copilot or Perplexity, but ultimately we have to use our natural intelligence to find out which is a suitable. First of all, whatever are 7 solutions given by this, whether any one of this will work or not, which one will work and why it will work. To finalize that, somebody should know about some basics about performance tuning. So always we have to use natural intelligence to use artificial intelligence. This is what I wanted to emphasize.
Explore our Oracle performance tuning and dimensional data modeling with eRwin tool courses. Upskill with our video courses at your own pace and time. Courses are created with real-world scenarios and ready to work immediately by industry experts.